Hello, welcome to the next episode in Making Terraria in Python. Today we're going to be covering items. Now there's a lot that goes into items in a game like Terraria, so let's get right into it. So there's a lot of different types of items. There's items that you can place, there's items that you can consume, and there's items that you can use, the items that you can attack with. So there are a ton of different types, and we have to be able to store them in the same way. And the way we're going to be tackling this problem is through inheritance, mostly. So let's go ahead and get into it. So I went ahead and organized a little bit. I created a world folder and I put the player, scene, sprite, and texture data files, as well as a new file I'm calling items inside this folder, just for organizational purposes. This is not required. I just think it is better to have it more organized. I've also changed the texture atlas. I just drew these little simple textures here. I thought it made it look a little bit nicer, just temporarily at least. And I've also made the adjustment to the size. It is now, whenever we're loading in the atlas here, it should be the size of 16 and the size of 16. So let's go ahead and get into actually using these items. So in the items.py, we are going to have a couple imports. So we're going to do from globals, import all. And then we want to import everything from sprite. So from world.sprite, we have to add that world now because it's inside of a world folder. Import all. And then I think that's it for now. And remember, the sprite folder, or the sprite file, is the one that contains the entity and the mob. So now in the items, let's go ahead and create a new dictionary. This is going to be a dictionary items, and this is going to be of type dictionary, and the key is going to be a string, and the value is going to be a data structure that we haven't yet made. So let's go ahead and make it. So this data structure is going to be a class of type item data, not to be confused with the item itself. And this item data is going to store a lot of different things, but let's just get it all empty so we can put it in here. And then we're going to set it equal to a dictionary here. And this dictionary is going to store item data for every item that we have in the game. So let's go to our texture data and check which items we need. We need the grass, the dirt, and the stone. So let's go ahead and add an entry here. I'm going to call it grass, colon, and I'm going to do a new item data object. And make sure that the names of the items here are the same as the names of the items in the texture data. It is pretty crucial to this system for that to be true. Now you can have multiple textures assigned to a one or vice versa. As long as these are valid for both, then it's okay. So now I'm go ahead and do Shift Alt down to duplicate this, make 3 of them, and then change them to dirt and change it to stone. But right now this is not useful. We just have empty item data, so we're not doing anything. So let's add some arguments. So the first thing we want to store for our data is the name of the item. It's going to be of type string. Then we're going to want to store the quantity. And this is going to have a couple different implications, but right now we're just going to have just a regular quantity. And by default, it's going to equal 1. And the next thing we're going to want to store is the groups that it's in. So the groups is going to be type of lists of strings, not a list of groups, a list of strings. We'll get into it in a second. And then it's going to by default equal the sprites, comma, and the block group. These are the two groups that the blocks are in. So it's the most, since most of the items in the game are blocks, I thought it would be nice to have the default be that, so you don't have to write it for every single item. The next thing is the use type, and the use type is going to be the tile that we import, or the entity that we import. So it's going to be of type entity, which is going to be the base class, and by default it's going to be an entity. The next thing is going to be the item type, and this is something we actually haven't made yet, so let's go ahead and make the item type. So we're going to have a base class for the item types. It's going to be class item. We're going to create the constructor here, and this is going to take in some arguments. It's going to take in a name of type string, a quantity of type int, and that's it actually. And by default, I'm going to set the quantity to 1 here. And yeah, that should be good here. Now what we're going to do is we're going to do self.name equals name and self.quantity equals quantity. I am now going to create a second class, and this class is going to inherit from item. It's going to be the block item, and in parentheses I'm going to add item, so I inherit from it. And this class is going to be a placeable item, which is just a block. And then we're in the constructor, we're going to def init tab, and it should auto create that for you. Now we're going to create something else. So every item is going to be usable, at least in some way. So we're going to create a use method inside of our item, send it itself because it's inside of a class, and then set it this special argument, which is arg, keyword arg. And if you go here and press enter, it should autofill it. This means that no matter what arguments we send, this use method will be called. We could send 1,000,000 or we could send 0 and it will be called. So now we're just going to pass it because the default item for now at least will not have any functionality. And in the block item, we want to override this. So we're going to def def use, send it self, and then for the block item, we want some arguments. We want the player, and then we want the position. The position is going to be of type tuple, and for now, we'll pass it. So now let's go ahead and finish this up now that we have an item. The item type by default is going to be an item, and that's all we need for now. So let's go into the constructor and let's actually store these values. So self.name equals name, self.quantity equals quantity, self.groups equals groups, self.use type equals use type, self.item type equals item type. Now it is all stored, so that's pretty cool. Now we have to give a couple different values here. So for all of these, it's required to send the actual name. So we're going to do grass, we're going to do dirt, and then we're going to do stone. And so now we have these item datas here. And what we're going to do in the block item is we're going to use the item data, and we are going to use that to actually place the blocks with the appropriate parameters here. So what we're going to do is whenever we use the use, we are actually placing the block. So we're going to do this. We are going to do items at self.name, which is the name that we store here. And then we're going to do dot use type. And remember, the use type is the type of entity that we're creating, whether it be a block, whether it be a platform or a chest or something. It's going to be one of these. Like we're going to have one here that'll be called like chest, and this will inherit from the entity. And because of how inheritance works, we will be able to use it and treat it like it's an entity. So that's pretty nice. So that's just a little bit of future sight there. So we're going to use type. And if we add a parentheses here, we are actually creating an object of this type. By default, it is entity. So we are going to be creating a new entity object. So let's go ahead and go to Sprite and see which arguments we need for an entity. So we need the groups, we need the image, and we need the position. Well, we can get the image from the player, and we can also get the groups from the player if we do a bit of tweaking, and we can also get the position from the player if we do a bit of tweaking. So let's go to the items here, and let's actually do this here. So for the groups, we're actually going to have to go back to our scene, and in the scene, we're going to have to change the arguments a little bit here. And so I've already kind of done it here, but let me just rewrite it for you guys. So we have our groups here, but let's actually create a list for our groups, or a dictionary actually. You can tell that I really like dictionaries when making games. So I'm going to do self.group list. And this is going to be a dictionary where the key is a string and the value is a pygame.sprite.group. And this dictionary will be equal to this. The first argument is going to be sprites for our sprite group, and the value is going to be self.sprites. And the second one is going to be block underscore group. And I like to do the convention of putting underscore group after everything, just to make it easier to remember. And then self.blocks for that group. Now, instead of passing where we had before, where we were passing the blocks, go ahead and get rid of that and change it to group underscore list. And then for the value, we will do self.group list. Going back to our player here, inside of the constructor, instead of doing the self.block group equals parameters at block group, we will change this up completely. We are going to do self.group list equals parameters at group underscore list. We now have access to every group inside of our scene. So now for convenience, let's just say the self.block group equals self.group list, self.group list at block underscore group. So now what we are doing is we are accessing this group list here, then sending it the key for block group and getting this block group back, which is pretty cool, pretty handy. So now we have access to all of the groups inside of our scene. We also have access to all the textures inside of our scene. So we have 2 of the arguments already completed. So let's go into here and let's finish them out. So the first one is going to be the groups. For this, we're going to do an inline for loop. So I'm going to do a brackets here, and I'm going to do player.group list at, and it's going to be group, and then we go outside of that for group in, and then we're going to do items at self.name.groups. What this is doing is it's mapping these string values to these string keys to their values in that group list we created. So it's crucial that these strings here have an actual group instead of this group list, otherwise things will break. So this is the first argument down. The next one is the image. For this, we'll just do player.textures at, and then we need to do self.name. The next one is the position, position, and we will just handle that in a bit. So we're going to send position. We want to add one more argument to our blocks here because we need a way to identify them when we pick them up. So let's go to the sprite here and let's add a new argument. So we're going to go to the end here and I'm going to add a comma and I'm going to do a name. It's going to be a string, and by default it is going to equal default. And what we're going to do is we're going to do self.name equals name. And what this is going to do is it's going to allow us to identify our entities a lot easier. So let's go into scene and let's fix this. So we're going to go down to our gen world here and we will change things up a little bit. Instead of directly assigning the texture here, I'm going to get rid of this and I'm going to create a variable called block type and assign it equal to dirt. And then if wherever we're assigning it to grass, we will do block type equals grass, and then we will do block type equals stone. Now this texture here, we are going to do self.atlas textures at block type, same effect here, but now we can go to the comma at the end and then do name equals block type. Now all of our tiles have a name associated with them, making it a lot easier to handle or work with them. So let's go ahead and get this all working. So let's go and make a new folder. We're going to create a simple terminal-based inventory for right now. So new folder, and this new folder is going to be called inventory. And I'm going to create inside of this an inventory.py. And I am deciding to make a dedicated folder to it because there's a couple things that we're going to be doing that will require, I think it'd be better organizationally. This inventory is going to have a couple things. So it's going to import everything from global. So from globals import all, and then it's going to have everything from items. So from world.items import all. Then we're going to create a new class, call it inventory, and then give it a constructor here. And then this constructor here is going to take in one argument, which is going to be the application, besides the self, of course. So we're going to do self.app equals app, and then we're going to need the screen in the future. So self.screen equals screen, or app.screen. Now what we're going to do is we're going to make some simple methods that we're going to need, some boilerplate. So the update method here, pass it for now, and the draw method here, pass it for now. And what we're going to do here is we're going to create a couple things. So we're going to first create our slots. So self.slots equals an empty list. And then we're going to fill our slots with stuff. I'm going to make 5 slots for now. I think that's pretty tame. So I'm going to do for index in range 5. And what we're going to do is we're going to do self.slots.append, and we want to append an item. We're going to append an item here, and we're going to do this. And actually, this reminds me, the default value should actually be 0. My apologies there. So it should be 0 here as well. Okay, let's go back to inventory. And now that we have that all done, we now have 5 empty slots for our inventory. Let's go ahead and add some dummy data to this to make it a little easier. So I'm just going to do self.slots at 1, which is actually the second slot because indexing starts at 0, equals, and we're going to make it equal to a block item. This block item, I'm going to just make it grass, and I'm going to make it 5 grass. Then I'm going to add another one just for fun and make it the third slot, so the second index. Make this equal to dirt and make this equal to 3. So now we just have some little dummy data inside of our slots here. We're gonna need to add one more thing. This is going to be the active slot. This is just an index position of our slot here. So it's going to be self.active slot equals 0, which is the farthest left. Now we're going to have to be able to change which slot we are targeting. So for that, we're going to need to be able to get input. So we're going to do from events import event handler. Now what we'll do here is we'll do if event handler dot clicked at and then we're going to do 1 here, I guess. Sure. Then we're breaking. So actually no, we don't want to do clicked, we want to do key down, because I'm just going to make it very simple here. If event handler dot key down, and then what I'm going to do is I'm going to do pygame dot k underscore right. Then this is going to be moving right in slots. Then what we'll do is we'll do if self dot active slot is less than the length of self.slots minus 1, then we'll do self.activeSlot plus equals 1. And then I'll do another one if event handler dot key down, and this is going to be pygame dot k underscore left. And this is moving left in slots. So it's going to be self.activeSlot is greater than 0, then, or we have to make it an if statement. If self.activeSlot is greater than 0, self.activeSlot minus equals 1. So we're just moving right and left in the slots, easy controls, easy stuff like that. And now what we're going to do is we're going to add a bit of debugging so we can actually see this. And this is what I mean by a terminal inventory. I'm going to be printing out the actual slots that we have here. And so for this, I'm going to create a new method. And this is going to be debug for me, self. And I'm just going to do for slot in self.slots, print slot. And then what we'll do is we'll do if event handler dot clicked any, then we will debug. The problem with this is that if we print the slots like that, we're just going to get like object block item at memory location, whatever. That's not useful to us. So let's actually change that. So let's go to our item here and let's create a new method here. This is going to be a dunder method standing for double underscore. So underscore underscore str underscore underscore. What this method does is it actually can override what the default printing is. So normally it will print the object and the memory location. Let's actually change that. So we'll return, and I'm going to return an F string, and this is going to be name colon, name colon, and then in the brackets here, I'm going to do self.name, and then I'm going to do quantity colon, and this is going to be self.quantity. So now if we ever print it, it will have this here. So that'll be cool. So now let's go back to the player here, and let's go ahead and get this all working. So first, actually, apologies, let's go to the scene and let's import the inventory. So for this, I'm just going to go to the bottom here, and I'm going to do from inventory.inventory import inventory. Let's go ahead and create this inventory. So I'm going to create a new section here. I'm going to call it inventory, and I'm going to assign it here. So self.inventory equals inventory, and this takes in the app. So it's going to we're just send in the self.app. Now we're going to add a new parameter to our player. I'm going to go comma, go down, and do in quotes inventory, and for the value self.inventory. And now before we forget, let's go to the update here, and let's make sure we actually call the self.inventory.update, and then we also call the self.inventory.draw. Even though we're not using it yet, we will in the future. So just in case, you'd be surprised how many times I've just forgotten to call the method and been debugging for hours. So now let's go ahead and create a variable inside of our player, call it self.inventory, and this will be equal to the parameters at inventory. All right, so now we have this inventory. Now, whenever we break in place, before we were just creating an entity no matter what, and we are just killing the block and not picking up anything. We don't want that anymore. We want it to only place blocks when we have them, and we want to get items whenever we break them. So what we're going to do here is we are going to do self.inventory dot, and then we're going to have to create a new method. So I'm going to call it use, and I'm going to go to the inventory here, and I'm going to create this new method. So this is going to be the use method. Send it self. And now what we're going to do here is we have to have one check here. We're going to do if self.slots at self.activeSlot. So this is the active slot that we're currently on. .name does not equal default. Then we're going to do self.slots at self.activeSlot.use. And this is going to take in the player and the position. So for this use, we are going to send in the player and the position. And this might change in the future, but for right now, this is what we're going to be doing. And so what this is doing is it's actually taking the, it's finding the active item that we are currently selecting. And then it is checking if that item is an actual item. It's not just an empty slot. And then if it is, we're using it. So we're calling the use method inside of our item here. So if it's a regular item, then it's not going to do anything right now because our use is completely empty. But if it's a block item, it will actually place the block. So let's go back to our player now. And in the use, we are now going to have to send it a couple things. So we're going to send it ourself, and then we're going to send it the self.get block position. And this is going to take in the mouse position here. And then we're going to get rid of this old entity creation here. And let's see, before we get carried away, let's see if the placing works. Missing one required argument, name. Yes, okay, we need to change that a bit. So let's go to items, and let's make the name default to default. So quotes default, okay. Go to main, run it, this should work. All right, so now what we can do is we can click, and you can see our inventory in the terminal. Let me actually disable my thing here. So if I click, you can see that the inventory here is popping up inside of the terminal. So we have the first slot is empty. The second and third slot have grass and dirt with 5 and 3, and then the other two have 0. And we are currently in active slot 0. So if we try to place something, you can see nothing is placing. However, if we press right, we are now in slot 1. So let's go ahead and right click, and we are placing our dirt. Of course, we are placing an infinite amount because we didn't have any restrictions on it, but that's progress. So we press right again, we're at dirt. So let's place it here, and you can see it's dirt. Right again, we are at an empty item, so it is not placing. So let's now add some more functionality. Let's go to items, and where we're placing the blocks, we will do this. If self.quantity is greater than 0, then what we'll do is we will create the item, and then we will do self.quantity minus equals 1. And then what we'll do is we'll do this. We will do this first. We will subtract it first. No, we won't. Sorry. We will do that like that. And then what we'll do is we'll do else, and then self.name equals default. And then we'll add another check here. If self.quantity is less than or equal to 0, then self.quantity or self.name equals default. And this is a little bit sloppy, but we can optimize later. Preemptive optimization is not always the way to go. So that's cool. Now we should have it in a way that it will only place things if we have things, and it will decrease every time we place. So we have 5 graphs right now. I'm going to right click. We have 4. I'm going to right click again. We have 3, 2, 1, 0. And let's try to place. We can't place. We go over to dirt. 3, 2, 1. Can't place anymore. So now it's like we have a proper inventory. Unfortunately, when we break blocks, we are not picking them up. So let's go ahead and add a little algorithm for this. So let's go over to the inventory and let's create a new method. This method will be add item. Send it self, and then send it item. And here we're going to have to do probably the hardest thing that we'll have to do this entire episode. So we're going to define some initial variables. So first available slot equals the length of self.slots. And I'm going to put a comment here. This is going to be the first empty slot. Then we're going to do the target slot equals the length of self.slots. This is going to be the first slot of same name. What we're going to do here is whenever we add an item, we want to add it to either the first empty slot or or if there's a slot that already has that is that item. If we already have a slot that is that item, then it's going to add to that one first, even if that's after the first available slot, because that's how Terraria does it. And so it requires a slightly funky searching algorithm. All we're going to do is we're going to do for slot in self.slots. And then we're actually going to enumerate it. So we're going to do index comma slot in enumerate self.slots. This is going to give us the index position of what we're looking for. And then we'll do this. We'll do if slot.name equals, and then we want to do default here. Then we will do another check. So we'll do and first available slot, or we'll do if index is less than first available slot, then first available slot equals the index. This will give us our first available slot. Then we'll do this. We'll do if, and we'll do slot.name equals the item that we are passing as an argument. So item.name. Then we will do target slot equals index. Now outside of the for loop, we will do this. If first available slot, or let's say if target slot is less than the length of self.slots, meaning that it's actually within the slot, it's a real one, then what we'll do is we will do self.slots at target slot dot quantity plus equals, and this is where the items come in. So we're going to do items, or we will do items at item.name.quantity, because remember, not everything drops 1. Right now it does because we haven't changed it, but sometimes, for example, you'll break like maybe like an or something, and it might drop more than 1. This is accounting for that. You could just make it so it adds 1 to all of them. If you want to just make it simpler, just make it add 1. I'm gonna do this just for future insurance. And then we want to do one more thing. So we'll do elif first available slot is less than length of self.slots. So this is if we didn't have a target slot, then we'll check our first available slot, and we will do the exact same thing, but instead we will put it in our first available slot, and then otherwise we will not do anything. We have to do one more thing. So we have to do self.slots at first available slot dot name equals item dot name. And the reason is because this first available slot will be empty, so the name will be default. We need the name to not be default. So now we are assigning the name and the quantity. Let's go back to the player and let's actually use this. So when we are killing the block here, where we are actually breaking the block, so breaking the block, we're going to add this self.inventory.add item, and then we are going to send it the item itself, and the item is going to be the block. And let's just make sure that's what we need here. We only need the block, so this should be all good. Let's go to main, let's press run and see if it all works. So we go over and we can check here, we right click, we place a block, we break it, and we have an issue here. I place the block and then I break it and it has default. And the reason is because we didn't add the name argument to that. So let's go to our inventory here, or let's go to our items, and wherever we are placing the block for the name here, we are simply going to put self.name. That should fix that problem. And we go to main and we press run, and now you can see that whenever we click, we are adding it to our quantity here, 7, 8, 9, 10. We are not placing when we are on the wrong slot, but if we go over to slot number 2 here, the second slot, we can place our grass. It decreases. Once we run out of grass, we can no longer place. We can go over to our dirt, place some here. We can break some stone, go over, and you can see our stone automatically went to the first slot because it was the first available. And we can place our stone if we can actually get there. Okay, so I just found the reason for why this isn't working. The reason is because whenever we have an empty slot and we're trying to fill it again, we can't just assign the name of the quantity. We actually have to create the new item for it. And the reason is because items have different functionality to them. So by default, we filled it with regular items, which the use method does not do anything. However, whenever we want to replace it with a block, we are going to have to assign it to a block item. And this will have the proper use functionality. Let's go back to our inventory here and let's change this. So instead of doing this here, what we are going to do is we are going to do self.slots at first available slot equals, then we're going to have to do items at item.name, and then we're going to do dot item type, and this item will take in the arguments. Let's go to the items and see the arguments. It's the name and the quantity. Let's go to inventory here. For the name, we are going to do the item.name, and then for the quantity, items at item.name.quantity. Okay, we have to do one more thing. The items for these, we're going to need to set the item type. So the item type is going to be equal to block item for all of these. And this will give us that functionality that we needed. So we're going to do item type equals block type here for all of these. This way we can actually place them when we use it. So now we are going to go to the dirt here, or the stone, place all of the stone. So now we have no stone in inventory. We're going to break some new stone. It now goes to the first available slot. We go to slot 0 and we right click and we can place our stone until it's empty. Same with the grass, we place it until it is empty here. And then if we break some more, we can place it again, hopefully. If it's, oh, it's in a different slot now. It's in slot 0. Let's go over there and let's place it. Nice. So as you can see, that now all works. Now it's a lot of gymnastics, like a lot of different back and forth, and there's no real easy way to do this kind of thing. So let me go ahead and give a recap of what we did here. So we have our block, and the block has all these different attributes about it. And then the block is sorted into different items. So when we are breaking the block, we have our player here, and the player breaks the block here. It then sends this block to the item data. The item data then processes it here and sends it and gives the appropriate item. Then the item is then sent through the item data whenever the player places, processed through here, and sends in the appropriate item. So you can see that we have to do a little bit of conversion for this in order for it to work. And let's do it in code terms here. So we have our item. We break the item. The item information is then sent to the item data. Or the item data here. We get this item data information and we process it. So we find the name of the tile we just broke. Then we get all these sorts of things like what groups should it be in and all that sort of stuff, and what item is it. So if it's a block item, then whenever we right click, we will be able to use it. If it's just a regular item, then we won't be able to do anything for now. And this way we can still store everything in the same inventory, but everything has a different functionality. And so this will make a lot more sense when we have multiple different types of blocks, why it's so complex right now. But this should make it very easy going forward because the hard work is done. Now we can have 13 billion blocks like this and they will all work perfectly fine. So That should give it a little bit of a nicer twist at the end. I know this was definitely by far the longest tutorial, but we did get the right result at the end, even with a couple of mistakes that I made in the process. But with that being said, thank you very much for watching. If you have any questions, which I'm expecting a lot of you will, make sure to join my Discord. I will answer them all, hopefully, and consider supporting me on Patreon. It will really help a lot with making these types of videos. So thank you very much. Have a good day. See ya.